Hello, everyone, and welcome back to the lecture series for implementing various programs corresponding to cybersecurity fundamentals. In this particular video, we are going to be looking at a use case scenario for secure file transfer, okay, which is basically a demo for network security and specifically the aspect of secure file transmission over a network, okay. This is implemented using Python, and we will be using socket programming as well as the SSL TLS security protocol, which is basically the fundamental or the core behind the security of all our network communications that we are using in this day and age. So what we want to implement in this particular program is basically a client server based application. So that will be one entity which will be acting or simulating the role of a server. And there will be another entity which will be simulating the role of a client. Okay. And our goal will be to implement a secure file transfer over the network. But in our case, the network is basically a local host itself. So it's not going to leave our computers, but it will stay within the local host itself. But typically, if you understand how it works on the local host, then you can change the relevant parameters to make it work over two different domains within a particular network as well. We will be utilizing the secure socket layer slash the transport layer security encryption protocol, and this will be utilized in order to preserve the data confidentiality and the integrity during the transmission of various files. So the security logic for the secure file transfer protocol is pretty straightforward. We have discussed this in class before, but what happens is, let's say you have a client who is running their systems in a particular domain, and that could be, let's say, your home server or your home network, sorry, not server. And then you have a typical server that, let's say, is running over a different network or a different domain. So let's say this is the university's domain, right? And our goal, that essentially what we want to implement, which we discussed here in this particular slide, is that the server has some sort of a file, and the client wants to download that file. And the server, when it sends the file over the network, so this particular range that you see here between these two yellow lines is basically the untrusted network, right? So when the server communicates that file over this untrusted network, the server needs to make sure that it is done in a secure way, such that nobody can intercept that transmission, gain access to the file, and figure out what is the content of the file, which will essentially compromise data confidentiality, right? In addition to that, it is also necessary that once the encrypted file is transmitted, nobody, or if anybody is tampering with that file, then the client would be able to figure that out as well, that the file that they have received is basically corrupted and should not be paid attention to, right? So that is basically the intention of this particular client, to get this file which is sitting with this particular server. So how would they essentially do it? So that is basically the forte of secure file transfer, right? That is what the protocol is enabling, and it relies on SSL TLS security, which is also something that our internet communication uses. Anytime we hop onto our web browsers and try to establish a connection with a particular server, may that be Amazon.com or your university networks, your Gmail and stuff like that, we always see a lock sign at the beginning of our URL browsers, right? So that is basically the indication that we are essentially, you have implemented the SSL TLS security protocol such that your communication with the server is secure from external snooping or tampering and stuff like that, right? So the first step in this whole process would be like, okay, the client would request a connection with the server, right? So that is basically a request to establish the connection. So when this particular event will be fired, then that will trigger the SSL TLS security protocol, right? So once that protocol is triggered, there will be a handshake like behavior that will take place. And what that means is, like, the client will say, like, hey, I want to establish connection with you. And then to that response, or the server will respond to that request by providing the client with the public key as well as the public key certificate that the server has already generated. Once the client receives that public key and public key certificate, then the client will use that public key to encrypt a temporary session key that the client wants to use for the encryption purposes of this communication. And that will be communicated to the server. So then the server, when it receives that encrypted session key, since it was encrypted using their public key, the server will use the private key that it already has and then decrypt and extract the session key that the client has communicated. And that will essentially establish a secure session between the client and server, because all subsequent communication that will happen between the client and server will now be encrypted using the session key, which has been now securely transmitted from the client to the server, right? So now if the client makes a request for transfer of this particular file, which sits with the server, and a session has already been established, what the server is going to do is going to take that temporary session key, which is going to remain valid only for that particular session, which has a duration, a timeout, and then it will use that session key to encrypt that file and then transmit that encrypted file over the insecure network. And then once the client receives that file, the client also has the session key, and so the client will be able to decrypt the file on their end, and then they will be able to read the contents of the file, right? So that is basically for confidentiality purposes, right? So how does SSL handshake, the SSL TLS handshake process works to implement confidentiality? Well, basically it uses a combination of asymmetric and symmetric encryption protocol. So the asymmetric encryption protocol is there to establish the session, right? So how it does it, as we discussed, a server.key file will be generated, and that will store the private key of the server, and the server will keep this essentially private. They will not share this with anybody, right? In addition to that, the asymmetric encryption algorithms always generates two keys, right? One is the private key and the other one is the public key. So the public key of the server is generally stored in the certificate file, which has the certificate as well as the public key, right? So you can verify as well as use the public key. So this is what is sent essentially to the user when the user or the client makes a request to establish connection. So once the connection is established, the server sends that public key certificate, and then the client can verify the public key. And then once the verification is done that, okay, it's a verified public key, it's not a forged public key by some adversary or attacker, then the client uses that to encrypt the session key that it can generate at its own end, right? And then it transmits that encrypted session key to the server. Now, since it has been encrypted with the public key of the server, and the server already has its own private key, so then the server can use that private key to extract the session key. And then that is when we say that a session has been, a secure session has been established between the client and the server, right? So now all subsequent communications will be encrypted using the session key. And for the protocol, we would, the server and the client would use some sort of a symmetric encryption protocol because it is much faster than asymmetric protocol, and something along the lines of standards like AES 128 bits, right? So that is basically how the confidentiality of the session can essentially be ensured by using the SSL TLS handshake process, right? Which is the security of our internet right now. There is also a matter or question of integrity. So like, okay, your communication might be encrypted here. I can encrypt the file, but what if somebody, intercepts the encrypted file, tampers with the encrypted file itself, and then relays it back to the client, right? So a situation like this, we say that the message has been corrupted, right? So even if the adversary was not able to figure out what is the actual content within the file, but they made it such that the client can not also understand what the actual content is, or if they are successful in terms of tampering the file without knowing the content, they might change the content altogether, right? So that is also a problematic scenario, and that is something that needs to be addressed within the topic of integrity, right? So what happens in such a situation, or how SSL TLS essentially ensures the integrity as well, is that once the session has been established, that means the session key has been successfully shared by the client with the server, or vice versa. When a message is being transmitted, right, or prior to a message, encrypted message is being transmitted, each message is encrypted and appended with what we call as message authentication codes, or in short, it's known as MACs, right? There are MACs, there's HMACs, so you can read this up on your own time. So these are basically hashing protocols, right? So that essentially, and we talked about hashing, we understand what hashing is, right? So then the MAC is basically a cryptographic checksum process, right? And that helps to verify the data integrity. So before the transmission, the server will compute the MAC, append it with the encrypted message, and then send it on its way to the client. Let's say if the data is tampered, like in between the transmission before it reaches the client, right? So once the message comes to the client can now also compute the MAC based on the message that it has received. If the computed MAC on the client side doesn't match with the appended MAC from the server, then essentially, as a client, you have an understanding that there is a mismatch between the MAC. So that means the message that I'm receiving and the message that was sent out, they don't match, right? So that's how you can essentially verify that integrity, whether it is preserved or not, or whether the message has been tampered with or corrupted, right? In addition to this, the server can also sign the message using the digital signature schemes that we have discussed in one of the previous demos for digital signature verifications, right? So you can check that video if you are interested in checking how to, develop your own digital signatures and then send it along your way to your destination, right? In order to make sure that the source validation can take place, right? That the client can actually verify that it is originating from the server itself, right? So that is basically the overview of the security protocol and some of the security concepts that we'll be using to implement this particular program. In terms of the programming logic, we are going to implement the operationality of a server in a server.py file. And that will, encapsulate all the server logic, everything that the server needs to do. So that means, establishing the connection, listening on a particular port for any type of request that will be made by the client and things like that. Then we will also have a client.py file, which will outline the client logic. So this will be to basically create a port connectivity, request a connection with the server, and then request a file to download for, which is essentially sitting with the server. We will also need a certification for the public key certificate that will be generated by the server. So here, typically, when we are creating a certification, right, we use some of the agencies or the authorities, certificate authorities that are available in order to sign the certificate, which essentially verifies that, hey, your public key is basically valid and anybody can use it, and they can use our certification to validate that you don't have a forged public key or anything along those lines. So the standard of certification that we use on the internet communications is basically the X509 certification. So we are going to be using the X509 certification for our implementation purposes. However, we will not be using any external certificate authority in order to sign our public key that will be generated from the server, right? So what we'll be using is basically a self-signed certificate. So there are a few steps that we need to take in addition because of this process of self-signing our own certificates for the simulation of the server, which is basically by default the OpenSSL protocol, right? The one that we will be using in order to generate the public-private key cryptography key pair, right? By default, it is not configured to accept certificates that are self-signed, okay? Unless it is coming from a certificate authority, it will not take any self-signed certificate. So we have to create a configuration file which will bypass this default restriction that the OpenSSL protocol has, right, when it is implemented using Python, that it accepts self-signed certificate. And the other change that we need to make to this certification information is that this certificate needs to be valid over our local host, right? Because we will be running this program on our own computers, right? Just to simulate the behavior between the interaction between a server and a client over a network. But we don't have like two separate networks here, right? So we are just going to be implementing on our own network, which is basically, in this particular case, it won't be even leaving our particular system, but you can make it work across different computers on different systems. That will be just fine, right? But we will see when we implement it, that when we do implement this, we will have to specify in the configuration file of this certificate generation that whatever certificate that we generate in this particular purpose needs to work for certain domain namespaces, right? So it's like where or on which networks will this certificate work. So there we have to specifically, tell OpenSSL protocol, which is essentially what we will use to generate the certificate, that, hey, I want to use this over my local host. So please keep that in mind and do not raise an error if somebody tries to use the certificate within the local host, right? And then we also need like a sample file. So you can call it a text file.txt or whatever txt file that you want to essentially use for this particular purpose, to simulate the fact that there is a file sitting with the server that the client requests and must be communicated over the network in a secure fashion to the client, right? So we will create this text file somewhere sitting in our root folder itself. Okay. In terms of dependencies, we need the OpenSSL module for our program. The reason why we need it is, of course, to implement the the SSL TLS protocol that we need to be using, right? So first thing is that this protocol, we don't want to, like, code it from scratch. We want to use an external module that will provide us with the logic on how to use that handshake protocol, right, that we discussed. The other thing is we also need to generate our certificate, our private and public, our private key, and then the public key certificate, which is the X509 certification. And for that, we can use the OpenSSL module, right? So we need the OpenSSL module for Python. So we call that the PyOpenSSL module. And a thing to note here is that when you run the pip install PyOpenSSL, most of the requirements that comes with or is there for the module will already be satisfied if you have already done one of the previous programs in the series, which was about the digital signature verification. So a lot of the components that this module needs as its own dependency for you to be able to install this are components from the cryptography library or the cryptography module that we used in the digital signature verification, because the whole process will involve, again, to generate public key, private key pairs, and stuff like that. So if you have already implemented that, then a lot of those things will be implemented, will already be present on your computer. It will just take care of the PyOpenSSL implementation. So we got to implement this first. The other thing is, like I mentioned, that we need a configuration file that will bypass the default security configuration aspects of the OpenSSL protocol, right? Which is to not accept self-signed certificate and stuff like that. So since we are self-signing our own certificate, we need to tell OpenSSL to trust self-signed certificates, right? And then to include localhost in the DNS information so that it works, that this particular certificate that we are going to be generating will actually work between the communication that will take place over our own localhost domain, right? So those are some of the things that we need to be mindful of, other than the program code or the program logic itself, right? So let us go ahead and switch on to our Visual Studio Code editor and start working on the different components. So we have a lot to go through again, but hopefully this will also be a simplistic program like the previous two. All right, so let's switch over to Visual Studio Code. All right, so here we have our Visual Studio Code editor, our project explorer. So what I have done till this point is, inside my root directory, which was cybersecurity fundamentals that we are using for all of the different programs, I have created a new subdirectory here, and I have named that subdirectory as secure file transfer. And then inside of the subdirectory, I have created one file which is going to simulate the role of a client. So it's going to role play a client's computer. So I'm calling that as client.py. And then I have created another file which is called server.py, which is going to simulate the role of a server, right? In addition to that, within the root folder itself, I have created a demo file, and I've named it as textfile.txt. And here we can give any message that we want, and we can say that this is a sample file which will be securely transmitted over a network from a server to a client. Okay, something like this. All right. So that takes care of the text file. You can forget about this text file. Just remember the name, because we essentially need to specify this information, because the client will be using the name of the file to make the request, and then the server will be checking that whether they have that file. And if they do have that file, they will be encrypting the contents of the file, and then they will be transmitting that to the client. And then the client will receive it, decrypt it, and then regenerate the file, essentially, right? So the only thing that you need to kind of keep a track of after you have done this is basically to remember the name of the file, right? That is essentially what we need. Okay, and before we can begin the program itself, the first thing is, of course, to make sure that you install the dependencies. So the one that we need here is the module called PyOpenSSL, right? So please make sure that you implement this first before you write any of the code that we are going to be talking about, because without that, it will throw an error for the SSL part, the secure socket layers operation part, right? So you can see here, there's a lot of requirements that are already satisfied. And this relates to the cryptography library that we essentially used for the digital signature verification program, right? And for you, essentially, once you run this program, it will just say successfully installed, hopefully, and you don't face any kind of error with respect to installing this particular library, right? So the next thing that we will do is start working on our server.py first. Let's write down like the process that we are going to be using. And we will remove this process essentially. Like, this is not specific to this particular code, but it's like the overview. So what I want to do is, first I want to generate the server, and then I want to generate the server's public and private key. Actually, before that, I need to generate the configuration file first, configuration file for OpenSSL. Okay. So we need to generate what we call as a .cnf file, which is a configuration file. And then once the configuration file has been created, we will use that configuration file along with OpenSSL in order to generate the public and private key of the server, right? So we will say service public and private key. And then we will write the client code. And then we will simulate it, right? We will run the code, run the server first, and then run the client in a separate terminal. Okay, so this is basically what the flow of the very big overview of how the program will essentially proceed, right? So we can remove this. We are not going to, I will hopefully remember this. But yeah. So this is basically going to be the program overview, like the entire program overview. Okay, so server code, generate configuration file, we'll say generate. Sorry, this is not generate, this will be create. Okay, and we will say write server code, create configuration file, and we can say use .cnf file to generate server's public and private keys, public certificate. Okay, so within the certificate, we have the public key as well as the verification of that public key. And then we will write the client code, and which will essentially make a request for file transfer, which is essentially this text file.txt that we have already created. So file transfer from server. Okay, and we can add a word here, and you can say securely. All right, so we run the server first, and we can say in a separate terminal, and then run the client in a separate terminal. Okay, so we need essentially two terminals side by side in order to get this thing to operate, right? Because these are two different entities, they're simulating two different systems essentially, but implemented on the same computer. Okay, so let's see what do we need to do for the server. So for the server, first and foremost, we need to have our import statement. So the first thing we need to import is basically the socket library. It's an inbuilt library. So this will essentially enable the socket program. So we can create a server, make it run on, bind it to a particular socket, and then make it run on it to listen for requests. And then we will do the same thing on the client, that we will start it on a socket, and then the client's socket will essentially make a request, and the server socket is listening. So you can think of it like two different windows that are trying to talk to each other. If the windows are not open, then you cannot communicate. So we need to open that window, and the client will shout out for a connection request, and the server is listening from their window, and they can receive that request, and they can start, doing the process that will be required to establish the connection. So that is basically socket programming, right? Socket programming, we need the socket module in order to implement that. The other thing is, for the security purposes, we will be using the SSL library. Okay, so that is something that we will take care of, right? So after this, what do we need to do? So we need to essentially first, let's write down the logic of just the server, right? So we will first write down the server logic of what needs to be done with respect to the server code. Okay. So of course we will, let's say, how do we implement this? So we can implement this, let's say, with one function, which will implement so this will implement the server. So that will be like create the socket on which it will run, or essentially this is, you can also call this the port, right? And then it will also listen. So create the socket. We can say bind server to that socket and make it listen to requests, something like this, right? And then we will have a main function which will run the server. Okay. Okay, and while running the server, we will need certain inputs here. So let's see, what do we need? We need essentially the IP address of the server. We need the port number, which is the socket, which we have declared here and binded the server to it. That will be fired up. We also, for security purposes, so here we will write security stuff. So for the security, we will need a server.crt file, which is basically the public key of the server and the certificate that verifies. So I'll just say public key. And then we also need a server.key file, which will essentially store the private key of the server. So when the server is executed, we must make sure that the server has all of this information along with it, right? So it will not communicate the private key, but it needs to communicate the public key, which is, and the certificate when a client comes and requests a connection, right? So the session can be established, the secure session can be essentially established, right? So let us go ahead and start working on this, right? So let's see, what do we need? So let's start. We will say we will have a function to establish secure server. All right. And then we will have a main function to run the server itself. Okay. So here, let us start with the main function. Let's see how this goes. So I can say if name equals, and this matches with the file name, then this will be treated as the main function. Okay. So what do we need here? The first thing that we need is the server's IP address and protocol. So let us save this inside a variable, and let us call this server address, right? And this server address will take two things. The first thing that it will take is the IP address of where the server is going to run. So for us, this IP address is going to be localhost. Okay, remember localhost, the IP address is basically 127.0.0.1. Okay, so we're not going to be deploying this anywhere else other than our own computers. And then we need a port number here. So let us choose any random port number. Let's say I choose 8443. Okay, some random port number, I have selected it. Please make sure you do not select a port that is currently being utilized by another service that is running on your computer. Because if you choose a port that is already in use, this program will throw an error. The server, when you try to run it, it will say that you cannot use it. So just choose some random, or you can choose the same thing. Hopefully nobody's using this port. You can use a port on the 9,000 range, 7,000 range, 5,000, 6,000 range. It's going to be just fine. Just choose something. But if you do get an error after choosing a random value, essentially the root cause of the problem would be there is some program or process that is running on your computer which essentially is already using that port. So there is a conflict that is happening. Okay. We also need to save the certificate file. So let's say we create a variable that will store the certificate file. Let us call that as the cert file. Okay. And then for the cert file, we have to give the path where this file is there. We have not generated the file at this moment. I think that would have been better. But anyways, so let's say we will name that file as server.crt. And the reason why I'm putting this here itself, because when I do generate this certificate using OpenSSL, I'm going to store it in the same folder as that of all of my different files. So that is why I wrote it like this. Let's say if this was in some other location, if I was generating the file from other location, then I would have to probably give the full path name of wherever this file is basically present. Since this file is basically present in the same location as that of server.py, I'm just writing the name of the file. So essentially, when you do something like this with the file path, then it looks in the same location of wherever this original file is within which we are naming this particular file, right? So we will name that. We also need a file to store the server's private key. So let us say we call that variable as the key file, which will store the path name of wherever the private key file is. And the private key files are generally stored in a .key extension, and the certificates are generally stored in a .crt extension. So that is why we have those extensions in place, right? And then we have to use the info above to call the secure server establishment function, which is the one that we want to write, after line 19 in the codes above. So here we need a function name. So let us give it a function name, and I'm going to say start secure server. Okay. So I'm going to start this. We'll figure out what the inputs are, but we kind of know that the inputs are going to be these three things, right? So we can fix that in a moment. So let us finish the prototyping here. So we leave it at a pass like we usually do. And then here, we are going to call this start secure server, and we're going to pass as an input to this program, to this function, the IP address of the server and the port number, the public key certificate file, which is the .crt file, and then the private key of the server, which is going to be stored inside a .key file. Okay, so once this is done, then we can essentially move on to our secure server here. So I can copy this guy here, and I can paste it here. Okay, so for the moment, let us remove this terminal as well. Okay, so that's a clean slate. All right, let's see what's going on here. All right, so once this is received, what do we need to do? The first thing that we need to do is we need to create a socket, okay, with the numbering that has been provided and stuff like that. So we learned this if you have done the program for the port scanner that I did in the last, I think the last video or the last two videos or the video before that, but we have already discussed about that socket process. So if you are curious about, some of the codes that will be written here with respect to socket programming, I would urge you all to watch that video about a port scanner that is implemented in Python. You can check the playlist library on the YouTube channel, and you can find that video. It's going to be the video either before this or the one that was uploaded one before that, right? So you can check that. So that has a clear explanation. So I'm just going to create the socket. I'm going to store it inside a variable called sock. And to create that, we are going to use the socket library. Inside that, there is a method called socket, right? And here we have to pass two input parameters. One is what is the IP address family that we are using, and that the fact that we are going to create a socket stream here that will be established with the socket whenever a connection request comes, right? So for the IP address, we are going to be using IPv4. So the way we do that is we use socket, and then we look for AFINNet. So here it is. So you can see here INNet 6, this is IPv6, and you have INET, INET, which is basically the IPv4, right? And then we need to create a socket stream here. So we're going to say socket dot sock stream. Okay, so we want the sock underscore stream. All right. So this is for our file transfer. So the file can be transferred as a stream. So that is how we are creating this particular socket. Okay. So the next thing, once the socket has been created, we need to secure the socket with SSL TLS protocol. Okay. You want to make sure the socket is secure. It's not an unprotected socket. So we're going to work on that. So the first thing that we want to create is we want to say, why are we creating this particular security for? So I'm going to store that in a variable or an object called context. Okay. And it's going to use the SSL library to implement the SSL TLS security. Okay. And here you can see there is a lot of stuff that is going on here. So we are looking for the create default context, which is essentially the purpose, establishes the purpose of why we are creating this security protocol. Okay. So for that, this is basically a method. The method takes an input parameter, which is again a member of the SSL module family. Inside of this, we are looking for the purpose. And then inside the purpose, we can see here, this will be used for client authentication purposes. Okay. Now, in order to do the client authentication purposes, we have to provide two things, which is one, the public key, and the other is basically the private key that will be used for the secure communication establishment. Yeah. So the information that is essentially required to establish the secure session, right? So for that, what we need to do is we need to take this context object that we have created in line 25, which is used for client authentication, right? And then we are going to use a method that is called as load certificate chain. I think this is the one. Okay, so we don't have default certificates. We don't need to verify location. Yeah, so I think this is the one. So we need to use load certificate chain, and then this will take two inputs. One is the certificate file. So the certificate file, we have named it as cert file for convenience purposes. We are not naming it differently. So this kind of helps us remember the fact that the cert file and the key file are basically inputs to the context that will be used to establish the secure connection, right? So then we have the key file. And again, the key file is stored in this particular variable here. So we'll provide that. Okay. And now we need to, this will essentially, we will execute this, and we will take the security information that has been now established in line 25 and 26, and we will wrap this particular socket that has been created in line 22, and we will store that in a secure socket. So what we are doing right now is basically we are creating a secure socket. So let us store it in an object called secure sock. So this is basically the secured version of the socket. And for that, what we need to do is we need to take this, and then we need to essentially wrap this entire socket with it. Okay. So we're going to take the context that has been created in line 25 and then provided with the information that is required to generate the security. And then we are going to call a method called wrap socket here, right here. Okay. And then in the wrap socket, we're going to pass the inputs of which socket are we trying to wrap. So basically that is the one that we created in line 22. So I'm simply going to say sock. Okay. And then this is happening on the server side. This process, this is not happening on the client side. So we are just going to say true. Okay. All right. So now we have created our socket. We have applied the SSL TLS protocol by providing it with the public private key information that the server needs to verify the client for the client authentication purposes. That's good. Okay. So now let's move on and do the next process, which is now we need to bind the socket to the IP address that has been provided when the server is running, and then make this particular socket listen to requests from clients. Okay, so that is the process that we need to do, right? So bind and listen is pretty simple. What do we need to bind? We need to bind the secure sock that we have created. Remember, we need to use the secure socket, then call the method called bind. And inside of that, provide the IP address and the port number on which this secure socket needs to essentially run, right? So that is stored inside this variable server address, which has been passed from the main method. So that takes care of the binding operation, right? It's like declaring the fact that, hey, this IP address and port number is what this particular socket will be working or operating on. So now we need to make sure that the socket that we have created is actually listening to requests from any user when this program is executed. So we are going to use the .listen method and set the value to 1. And we need to give a prompt to the users, that is us, so that when we run this program, we actually know that this program is running. So we, in a formatted way, we will say that secure, what should we say? Secure server has been started on, and now we can use the server address. Okay, whatever server input. So essentially it will say localhost, and then it will say this particular port number and stuff like that, right? So, all right, so that takes care of the server socket. And then we need to handle. So here we will say handle the client request once it is received. Received, or is it CEIV? I don't remember. Anyways, once it is received, let's put CIEPED. Let's keep it this way. Hopefully, this is the right spelling. All right. So essentially, what this is that, hey, I have now bound the server address and the port with the secure socket that I have created in all these operations. Here, it's now listening to requests. So what happens if a request does come? How should the server essentially operate or function when a request is received? So what do we want to do is we want to start an infinite loop first, right? Because we don't know how long this request is going to continue or how big the request is essentially going to be and stuff like that. So we're going to set up an infinite loop first. And in order to do that, I'm going to be using the while loop. And I'm going to set the condition of the while loop to be true. So since the while loop condition is always true, this will essentially become an infinite loop, right? So what we are going to do here, this is what kind of request is going to be received. We know for a fact that this is a file transfer protocol, right? So the type of request that will be received on this particular socket will be for file transfer, right? So what we need to do from the server's perspective is that the server needs to first check the request, see if it has the file with it. If it has it, then it will transmit that file, okay? If it doesn't have it, then it will give a notification that, hey, I did not find the file that you were asking for, and it will close the connection with that particular client, right? So that is basically the idea of what we want to do. So for that, we are going to create two control variables here. So we are going to call the first one as connection and the second one as address, and we're going to assign this from the request that will be received by the secure socket, right? So secure sock is that, and then once it receives the request from the client, from there we will extract the connection, where the connection is coming from, and what is the address of that particular connection, right? So we will extract that, right? And then we can give a return prompt, and we can say that, hey, I have received a connection from, and then we can give the IP address of the client who is requesting the connection. Okay. Now, the way the client is going to establish the connection is by providing the name of the file that they want to download from this server, right? So the server essentially has to extract that file, okay? And that file will be sent in byte stream, right? So it has to decode that information and then, store it in a way that it can understand. So I'm first going to create a variable that will be able to store the name of the file that has been sent by the client, okay? And then this will be present. This information will be present inside the connection information, okay? That is, we are storing it here from all of the accept information that is coming, right? So the connection information will call the received method, which is recv here, for 1024 bit stream, okay? And then we will essentially decode this so that we can store it in a way that we can understand the actual name of the file that is understood by user and stuff like that, right? So we can create a return prompt here on the server side in order to make sure that if we do face any error when we run this program, then we can actually validate that are we receiving the correct file name or is the error coming from something else, right? So we can say something like requested file by the client is, and then we can give something like this, and then we will output this particular file name, just double check that, we are able to transmit the correct file name and the server is decoding it correctly and getting everything, right? So now once we have received the file name, then what do we need to do? We need to essentially create a try catch block, okay? And in the try, we want to first read that particular file. So essentially here, the whole idea is that we want to make sure that, I have received a file name. I will check in my directory whether that file name exists. If it exists, I will transmit it. And then if it doesn't exist, then I will throw some sort of an error, right? Something along those lines. So here we will do a file input output attempt. So we will use with open. Okay. Here we will provide the file name. So we'll just say the file name is this, stored in this particular variable. We will open it in the read B mode, okay, for the bit stream, for the bit reading mode, okay. And then we will create an iterator that will go over the particular file. And then whatever information is read, we will store it in a variable. Let's call that variable as data. And that will be populated by the file.read operation. All right. And then once all the information is read from the file, then we will take the connection that is currently established between the session connection that is established between the client and the server. And then we will essentially look for a method to send it. Okay. So here we will use not one by one, but we will send everything that we have created in line 43. So we will use the send all. We'll just take the entire data that is present in the file, and we will just send the whole data. Okay. And then that is the end of this file IO operation. So we can use a prompt here and we can say that, hey, server has sent the file, and we can give the file name here, essentially, that was received from the request. Okay. So now, the other thing that can happen is whatever the user is requesting or the client is requesting, it does not exist with the server, right? The server has nothing, no file, no such files, right? So that will be written within the except block of the try catch except block. Okay. So here, what happens or what we want to do is that if there is a error that says file not found error, not the exists error, we will say file not found error, this one. Okay. So if that error happens, then we will tell the client first. So we will say client send. So we want to send a single message here. So we will not use send all. There is nothing to send here in terms of all. Okay. And this will be formatted in not a string mode, but in the byte mode. Okay. Or the bit format mode. And we will say file not found. We can say try with a valid file. Something like this. Okay. So that takes care of informing the client, and then we can create a prompt to log that information on the server side itself. And here we can say file not found. And this, so the 49 will be shown to the server on the server's terminal, and then 48 will be shown essentially on the client's terminal. Okay. So once that is taken care of, the last thing that we need to do is, regardless whether the operation was successful or the operation was unsuccessful, we will close the connection that has now been, that was currently open between the server and the client. Okay. Yeah, so that should be all. Let me just double check what I have done here. Created the IP and the port. We need to still work on this. We have not created these two files, but I need to generate this within this particular directory itself. One is the public private key. Boom, that's done. Create the function that will establish the secure connection and the file transfer with all of these inputs. Then we can go to this. We create a socket, say that it is IPv4, and then the byte stream will be created for exchanging data. Then we create the security part. So for that, we use the SSL module, specify the context that the purpose for this is for client authentication. We load the information that is necessary, which is the public key and the private key, and then wrap the socket that we have created here with the information of the context in the previous two lines. And this is for the server side. We bind the socket. We listen to requests, give a prompt that the server is ready to receive requests. When a client request is received by this, we accept that, and then we extract two different information. One, where is this request coming from, and what is the context or the content inside the connection. If you guys are interested, you can do a print of the connection object here and the address object here to see what is the full content. and not just the address. We convert the byte stream to string, okay, so that we can essentially understand. So you can see here, this will be received as bytes, zeros and ones. So we need to convert that into string so we can understand what the file name is, double check that on the server side, then try to see if that file exists. Then we read that file, store all the information in data, and then send all the data again back in byte stream. And that's the success operation. And if the file is not found, then we send a notification to the client in byte format. Whatever this message is, it will be converted to bytes, and then it will be sent. And then on the server side, we will print this, and then we will close the connection that was established with the server, essentially, that particular connection, right? And this is already taken care of. All right. So the next thing that we need to do is generate these two guys here. Okay. So for that, we need our terminal for a second. So I need to fire up my terminal here. The first thing that I'm going to do is inside the root directory. So first, make sure that I'm in the correct folder. Yes, I am. So I'm going to create a new file, and I'm going to call it open SSL.cnf. So .cnf is basically for a configuration file, okay? And in this configuration file, I'm going to provide some information such that I can use that information to create the, where is it? To create this guy here, the server.crt file, okay? Two things to note here. If we do not create this CNF file and use it for the generation of the certificate, then we would have some sort of a interactive operation that will be going on, which will essentially require us to, provide the information in the terminal. So let me show you what needs to be done in order to generate the certificate first. So I need to write or use the OpenSSL module to generate the certificate, right? And then there is a requisite, and this will be a new certificate. It will be using the X5 X.509. So I think it's written as X509 itself. So 509. Okay. So that is the type of certificate. Key out on the output. We will be storing that key in a file called server.key. And then we need to also output one more thing, which is the public key and its certificate, which will be stored in the server.crt file. We need to specify how many days this certificate will be valid. So that will be given by the days flag. And then we can say something like it will be valid for 365 days, right? And then it will be used for all different nodes there. So you can see, this is what I mean when I say that if I do not provide a configuration file, then it will start an interactive process with me where it will ask for certain information, right? So I can say something like US, and then I can say, okay, province is Michigan, and stuff like that, right? So I can say locality is, I don't know, Saginaw or something like that. So you can understand that I don't want to go through this process, right? I don't want to like interact here and make it more difficult. So that is why I'm creating this configuration file where a lot of this information that will be required by this process will already be present in that configuration file, right? So it will not bother me when it is going to create it. You can see here it already has created a public cryptography public key, private key. So I don't need this guy. And I did not go through the process, this whole process. So it did not generate the certification. It did not generate the public key and the certificate, right? So I want to avoid this discussion with on the terminal in the process, for the process of creating the certificate and the private key, right? So I'm going to write the instructions here in a separate file and run that particular command by providing the file as an input, and then it will take care of this whole business there, right? So I don't have to worry about it. Okay. So let's see. To write a comment in a .cnf file, we write a pound symbol. Okay. So a hashtag or whatever. And then that indicates essentially a comment within a CNF file. So why are we writing this? Essentially, we want to configure and customize the behavior or the functionality of open SSL commands. Okay, and what is OpenSSL commands? OpenSSL commands was basically this is an OpenSSL command. Okay, so I don't want to provide all this information here. I want to provide all this information here. And when I run this command, it will just smoothly go through without bothering us too much. Okay. There are a few things that we have to kind of, bypass some of the default configuration information, which would create an error in our particular case, because we are running this in the local host, right? So generally, this is not meant for local host, and it's not meant for certificates that are self-signed, that we are signing our own certificate. It's generally, in a much more practical scenario, not trustworthy that you are the person who signs your certificate and then say to somebody else that, hey, trust me, So the only thing that is going on there is your word that trust me. But if somebody else does it and it's a valid entity that can be trusted, like, a trusted third party, then that is more trustworthy than self-signing. So that is why we have to bypass this process, right? So we can essentially, using this file, define some settings, okay, which can outline things such as distinguished, I hope I spelled this right, name fields, okay, and then other parameters that is required in this particular category of generating a certificate, which is called subject alternative names. All right. This is basically categories inside DNS. So you can read more about DNS to understand what these specific fields are. This is in short also known as SAN. But the whole idea is that think about it this way. What we want to specify using these fields is that, hey, this certificate should work for the local host network, okay? And the local host network would have, if it has any alternative names, such as if you refer to your local host, I'm hypothetically speaking here for you to understand that if you want to refer to the local host as, let's say, example.com, right? So if I use this certificate with an example.com, then the certificate will be generated in such a way that when it will be used by the client to the server, or when server to the client, right, then it can understand that, okay, I have generated this for this particular network domain. I'm still within this network domain, and this is the host that it is coming from. So I get it, right? So that is basically what the alternative names are. It's like your nicknames, right? So you have a proper name, and then that is basically your IP address. And then if you have a nickname, which is basically the domain name, right? Then what are the different domain names that maps to your actual proper name, right? So that is some of the information that I can specify here. Okay. So the first thing that I want to do within this is, configure the certificate creation request. All right. So this is essentially written within this section called rec. All right. Anytime we want to create a section within this file, we wrap it in third brackets and we use the keyword that indicates what this section is about, right? So this section will have all the information, the generic information. You will say like, hey, you can find this information in this section of my file, this information in this section, this information in this section, and any other additional options that you want to provide here. So basically, this is like the overall configuration. So let me write 1 point down. So let's say, how do I tell OpenSSL where to find the distinguished name that will be used for this particular server, right? So I will tell them that that information is present in the section which we will create in this file, and we are going to name this section as REQ distinguished. I need to be very careful not to make a spell mistake here. Okay, so REQ distinguished name. All right. So I will create a section just like rec here, somewhere down this file, which will be named this, right? So if the file comes and looks for distinguished name, I'm basically telling OpenSSL that, hey, go to this section and you will find that information there, right? So that's all I'm doing here, right? So I'm setting up the file. So the other thing that we need is the X509 certificates. So that's the certificate that we are using here, right? So we will say the X509 extensions that are required in order to work with this certificate. Please go and look for it in a section in this file, which will be called as v3 underscore REQ. Okay, so this is basically the extensions that are required to generate the X509 certificates. All right, and we also do not want any kind of interactive prompts that we saw here. We don't want it to talk to us. So we basically want to disable the prompt. So we will say the prompt. So these are all reserved keywords. Okay, these are all reserved keywords. These are not like variable names or something like that. Okay, OpenSSL understand these keywords, what it is. Okay, so we're just going to say that the prompt is. Okay, so now we need the first section that we have defined here. So again, if you want to create a section in this .cnf file, you put it in the third brackets. So I'm going to put it inside this third brackets. So what do I need to do here? What I want to do here is there is this field called common name. Think of it like the proper name that people know you with, right? You have one field, which is the common name, and then you have other things like the alternative names or the SAN names, right? So I need to set the common name. Okay, so I want to set the common name to localhost essentially. That is what I essentially want to do here. So what I'm going to do here is I'm going to create the field of common name, which is typically known as CN. Okay, that is the keyword that this particular OpenSSL understands. And here I'm just going to write localhost. So it allows me to use this certificate in the localhost domain. If I do not specify this, then this certificate that I was trying to generate here without the specification, it wouldn't have worked because it wouldn't have known that where this certificate is essentially valid. Where can I use this certificate? So in order to make that happen, under the distinguished name field, there is a field called common name, which is given in the short form of CN, and that I am assigning localhost to that particular common name. So whenever the certificate gets generated, then it will work over our localhost. Okay, if we do not do this, then this particular demo will not work. So let's see what is the next thing that we have. We have the v3 rec section. Okay, so this is essentially for alternative names. Okay, so if you have multiple host name that maps to a particular common name, right, then you can provide those information here. So that field is known as subject alt name. All right, and here we will say @alt underscore names. All right, so we are creating another directive here that, hey, if you're looking for the subjects, this is the subject, alternative name, that is how else this common name is referred to as, then please look for a section which is called alternative name here, right? So then we'll come here and we'll create this alt names section. Okay, so within this section, we are going to list all of the different domain names that will be there. So let's say the way you do it is by using this syntax, which is DNS.1. So this is your first nickname. Think of this as your first nickname. If your proper name was your IP address, then your first nickname that, oh, if this nickname is used, then I know that it maps to this particular localhost. So if I'm within this DNS, then it is, the certificate is still valid because this is associated with this particular common name, right? Because that's how we are tying the certificate generation as. So we don't have a separate name here. So we are just going to put DNS localhost itself. Remember, I can add more DNS here. So I can say something like example.com if that maps to this, right? So then this certificate will also be valid within example.com host, right? So we don't have any example.com. So we'll just leave it at DNS1 essentially, right? So let me see if I have everything ready here. So I have created the initial configuration, said that you can find the distinguished name in a section called rec distinguished name. Here we have declared the common name to localhost for the X509 extension. It's using the alternative names. Okay, the SAN here, this is also known as the subject alternative name or SAN. Okay, and then you're saying this is declared in another section called alt names. And then the DNS, the first domain name space is localhost itself, right? So we don't have any variations of this. So yeah, so we need this OpenSSL information essentially in order to run this. So now when we run this command, now we are done with this. We can close this. Hopefully we don't hit any error due to some sort of a typo. Then now we can create this public key and private key, but using the configuration file. Where is it? Here, that we have created. So I'm again going to call the OpenSSL SSL command. Okay, REQ dash new, I'm generating new X509. That's the nature of the certificate. Keys out to a file called server.key. Okay. And then I need another output, and that will go to the certificate file, and I will say certificate CRT. And then I need the number of days that this certificate will be valid. So I will say 365 days, okay, and use for all nodes. And then I have a configuration file, and this configuration file is open SSL.cnf. Remember, if your file is not stored in the same location as the root directory where I'm currently logged in, then you will have to provide the full path name here. Okay, so let's hit enter. Okay, so we hit an error here. So let me see what mistakes have been done. And we will follow the same suit. I will check where the error was, and we will fix this. So we didn't get this error when we ran the previous command, right? So did I give an additional space or something like that? Let's try this command again and see if it does the same error. Yeah, so it's having some problem here. So have I made any typographical mistakes anywhere? That's the first thing I would like to check somewhere. So I guess we will pause the video and we'll try to see if we have any type of error. I'm just quickly checking for any type of type error. So let's see. OpenSSL 365. How about we do something like this? How about we clean this up and we find the command that actually ran, which was this one, okay? And to this, I will just append. I just need to append this config flag to it, right? And I will just want to say open SSL.cnf, right? Okay, so it worked. Maybe I made some typographical errors in the previous one, although at least right now, I cannot check if I put an extra white space or did I do anything differently. I'm not sure. But let me give you some helpful suggestion here, because if you try to run this command on your own terminal, you might get a similar problem. So what you can try doing is you can write this whole command in, let's say, a notepad or something like that, and copy paste from there into your terminal, okay? And try that out and see if that works out. So anyways, moving on. You know, sometimes you don't know why it's working, and you don't know why it's not working at times, right? So anyways, so let's see. So we now have a server.key that has been generated. So this is basically our private key. All right, pretty sweet. We don't have to worry about this. And then we have our certificate file here. Okay, so you can see the certificate is basically a private, a public key that will be provided to the client. So that takes care of the certificate. So now if we go back and check our server here, now we have server.crt, server.crt, server.key, server.key. And then this is basically a static input, so we don't have to worry. So we have all the inputs that is actually necessary to run this particular code. So let's see, what do we have? We have written the server code, so this is done. So we'll put a check mark here, done. Then we have create configuration file for OpenCSL, done. Then generate the keys, done. And then we need to write the client code. So the next thing that we need to work on is essentially the client code itself. So this is also going to have the two imports that we need. One is the socket, and the other one is basically SSL. All right. It will also have a main function. So let's see, what do we need to do here? All right, we need a function to establish connection with server, secure connection, by the way. So let me say secure, and then a main function to fire or execute fire the client. Okay. All right, so let us do the same thing. So let me just write the main function somewhere down here. So if underscore underscore name is equals string underscore underscore main underscore underscore colon. So what do we need to do here? We need to provide the server address. Okay, so we would go with the same structure. So the server address, where is the server running? The server is running on, where is the server running? Okay, here. So I will just copy this. so that I don't make any mistakes trying to type it out. Okay, so this is where the server is running. Then I don't need to provide the secret key and stuff like that. What I do need to provide is the file name that I'm trying to request, because I think that is what we are going to request the server for, right? So I'm going to say here, I want a file, and I want to make sure that I use a file that the server actually has, which in my case is going to be this text file.txt. So I'm just going to say, I want a file, text file.txt. Okay? And that takes care of the file name that will be sent as a request and then to be decoded by the server. And the server can essentially use that file. Okay. And now I need a secure connection, or basically I need a socket connection that will send that request to the server socket, right? So let me say I want to have a function here. So I will say def download my file. So that is what I want to name my file. We will figure this out if it has an input parameter or not, and we will leave this empty for the time being, because I want to use this function call, and I want to call this function here. To this, I want to provide what? First, I need to tell it, this is the server that you are contacting, and this is the file name, I believe. Yeah, this is the file name that I want to send it. So I can take these two guys here. I can push it here. And now I can start writing my code here. So what do I need to do? I need to follow the same set of process for the server. So that essentially means we want to create a socket for the client first so that the client can communicate. So I'm going to say, I can just copy paste it from here. I don't have to write separately for the client. It's basically the same operation. So I will just copy this line of code from the server. And then I will just put it here. So that will create an IPv4 socket stream. And the next thing that we need to do is basically wrap the socket with security. Okay, we also need to wrap this with SSL/TLS, right? So this is going to be the same, but I think we need to flip. Instead of client authentication, this will be for the server authentication. And we don't want to provide the, what do you call it? The server's private key this time, but we need to provide the server's public key. That is what will be used. So let's write it down one by one. So first we need to create a context, store a context, which will be created using SSL. And we will say create default context. Okay, and why are we creating this context for? So we will tell SSL using the purpose method, okay, or the purpose property, that this is for not client authentication, but server authentication. This is what we need it for. Then we need to take this context, and then we need to use the method load verify, where is it? Here, location, all right? So we don't need the certificate chain this time. We need to verify the server itself, okay? And we will say server.crt. By the way, when you verify this, this is where you have the common names and the domain names and stuff like that, which has been used to create the server certification. So if we do not have the location information where the client is requesting from or checking it from, then it will throw you an error and say that the SSL certificate is not valid. So you won't be able to verify it. So this is basically verifying the server certificate. Okay. All right. And then once that is verified, then we need to wrap it and create a secure socket. So we will say context dot wrap socket. And for this, I will provide the socket itself, which is in line 11. And then I will take the server host name. And this is basically the server address that has been provided by the client. And we can give the first part of the address. Remember, this is an array. So this is index 0. This is index 1. So essentially, I'm providing index 0 here. That is why you see this third bracket 0 here. Okay. And then once security has been created, we need to establish connection with server and send file request. That is what we want to do next. So I will take the secure socket, secure sock in our case, and then I will hit connect here, and I will provide the server address essentially to connect with that particular server. and then I will send my file request or the name of the file that I want. So I will take secure sock.send all. This is the one that I want. I will take the file name, which is right here. And then I need to encode it into the byte stream. So I will call the encode method. So it doesn't send it as a string, it sends it as a byte stream. Okay. And then what will happen? When I send this request, the server will go through all of this code here from line 34. Okay. And it will send a response back to the client. So now I have to receive the server's response and, operate accordingly on the client side. So here I will say receive server response. And within bracket, I will say hopefully with data, right? So we don't know if it's going to send an error or the actual data itself. So let's say if it does send the data, then we'll again create a file IO operation. And then here we are going to say with downloaded file. Okay. And we will say the name of the file is basically file name itself. So not this file name. Okay. And we are going to open this using the write byte mode, bit mode. Okay. And then as file, and then we will bring in the iterator. So we will say while true. Okay. What do we need to do? We need to essentially receive the data and we need to store the data in an object. So we'll store it here. And we are receiving the data from our socket using the recv method, 1024 bits. Okay, at a time. All right. And if no data is received, so we can say if not data, if we are not receiving data, we are receiving something else. So we will break out of this function. Oh, no semicolons. Okay. Python doesn't have semicolons. Force of habit. And then we can take the file and then we will use the write method and then we will just dump the data into this new file. So I'm doing this essentially so we can recreate that file at our end, okay? Because we don't get the file. We essentially, what the server does, it takes the file at its own site, encrypts everything, sends it as a byte stream. We receive that byte stream and then we recreate that file for our client to view it, okay? So, that is how we essentially operate. So now we will get out of this while loop. We'll get out of this file IO operation, and here you give some sort of a prompt to the client where we can say downloaded file successfully. All right. For file, and we can say the file name again here, some sort of a prompt just to do a sanity check that everything just worked fine, give some information. And once that is done, we will call the secure sock and close the connection with the server, essentially. Okay. And that is all that we need to do here on the client side. Create a socket, wrap it with security, establish the connection with the server, verify everything, give it the file name, receive the data back. If it's not a data, we stop and then throw whatever error is there. Or if we do receive the data, we write it to a new file. That is essentially we recreate the file on the client side after decryption, and then we close the connection. So once this is done, I think we are done. And let's see how many errors do we get now. All right. So hopefully everything goes smoothly, but we will figure it out. All right. So for this, the first thing that we need to do is we need to fire off our server. We need to start our server. So in a terminal, okay, I'm going to make sure that I'm in the correct folder. All right. And now I'm going to say Python server.py. Okay. Remember, there are many servers here. I could have given a better name for this guy, but it's okay. And then we need to start this. All right. So now we have an open socket running on this, which is secure, by the way. All right. And it's open for communication to receive a request from the client. Okay. So now to simulate the client, we need to open a separate terminal. So from Visual Studio Code, I'm going to click on this drop-down arrow. I'm going to look for split terminal, And from here, I'm going to select another git bash. If you do not have git bash installed on your computers, then you can use command prompt or PowerShell. Okay. So I'm going to use git bash because it allows me to use Linux type commands. And next thing I want to make sure is I'm in the right folder. I'm not in the right folder right now. So I need to get out of here. I need to cd into my cybersecurity fundamentals and then my secure file transfer. Let's clear everything out, make sure we are in the correct folder. So we list all the files that we see here. I can see the client.py here. So I'll clear this out again, and then I will do Python client.py. Now, if everything goes well, I should see a new file that is created in this folder, and otherwise I will see an error. Okay, so everything went well, and let's see what happened. All right, so here on the client side, file was downloaded successfully, and I have created a new file here which says downloaded text file, so it kind of distinguishes from text file. The content is going to be the same, but the idea is once when it was transmitted, understand this. The server had this file which had this content. When it received the client's request with the file name, it saw that, okay, I have this file. So it extracted the contents from this file, encrypted everything, transmitted it as a byte stream. The client received that information, decrypted everything, recreated that file, and then pasted that information there. We don't see that internally, but that is essentially what is happening, right? So the other things, you can add more print statements here for the connection, for the request to see what else is happening when that information is received. So you can, for each of these different areas, so for example, you can print the entire connection, you can print the entire address, and you can check what is happening. You can get more information. You can see where the client is coming from. Remember, this port number is for the server, right? So this is where the server is running. But the port that was randomly generated for my client, when I created this socket here for the client, right? And then I went for all of this different information. My client is running on this particular port on my local host, okay? So these are some of the things that you can check out for your submission, for your screenshot. Essentially, you would screenshot your project directory, and there are no multiple demos here. You don't have to test multiple cases. All you have to make sure that you have a screenshot like this, okay? Or it could be two different. If you cannot do the side by side, it's okay. But you need to make sure that your server is running when you run your client. Otherwise, you won't be able to run this program, right? So this is basically the expectation of the output. And of course, make sure that you understand this code. And if you are required to write a documentation of this code, then please make sure that you explain each code line by line and give the overview of what this code essentially does, right? So this is basically how you can implement your very own secure file transfer protocol and implement SSL and TLS. This is also the basis on how internet security works as well. So I hope you have a better and deeper understanding, reinforcing the lectures that we have gone through while discussing network security and the TLS protocol. And then I will see you all in the next video, and we will talk about probably, I'm not sure yet, but maybe malware analysis or intrusion detection systems, a mock intrusion system. So either one of these two. So take care, and I will see you all in the next video.